Okay, so today what we're going to do, we already took the notes last class for today's lesson, so you don't need notes today. Instead, we're just going to jump straight into the lesson. Now, the nice thing is, this is just building on what we just did. So we just explore these equivalent ratios a little bit deeper and be able to put this all together. All right, number one here, we're going to start with our marking the text. I will tell you guys, one of the big problems that I noticed, I had a lot of kids coming to the seminar needing extra help today, which is awesome. Love that. Please come seek extra help if you're needing it. But what I found, 2-8%, those who needed the help were people who are not marking the text yet. Guys, I will repeat again. We are going to be doing basically 100% word problems with the CH New York. So you need to get used to how to solve these word problems. It starts with breaking the problems down by marking the text. You understand the information and what's being asked. And that second part is probably the most important, because if you don't understand what's being asked, you're not going to get the question right. So as we break this out, the morning announcement said that 2 out of every 7 6th grade students in the school had an overdue library book. Jasmine said that would mean 24 of us have overdue books. Grace argued, no way, that is way too high. How can you determine who is right? There's our question. So we're going to box that. So they've given us quite a bit of information in here, right? So let's kind of break that information down so we can see what we need to understand to determine who is right. So what was the first piece of information they gave us? Yeah.
The morning announcement said that 2 of the 7 6th grade students in school had a library.
Good. So what can I make out of that? 2 of 7 is a ratio. Okay? So I can make my initial ratio. 2 of 7 have an overdue book. Good. Okay, so following what we did the other day, let's go ahead and make a tape diagram out of that. So we have 2 with overdue books out of 7 total students. So the overdue out of the total. Make sense? Okay, so then what did Jasmine say?
44 students had.
So now how do I use that information as a representation in my tape diagram? Does that help me any? What does that 24 mean for the information that we've been given so far? What do you think? 24 students in total? Is that what it says? 24 total students? What's it say? Overdue books. So can I use that information with what else they've given me? I think, Bob. Why do I have it divided by 2?
Because there are 2 out of 7.
Because there's 2 out of 7 that are overdue, right? So that gives me, what's that math term we use? No? Good. There's a word before it. You almost got there, Quaffles. Not quite big brain yet. You're getting there. What was the other part of the word? What? Ratio constant. So that means I have a ratio constant of 12. Make sense?
Yeah.
So what's awesome about the ratio constant is every box gets it, right? So now I know what about the total. Yeah.
You can multiply 7 by 12 to get the total.
Awesome. So now let's get to the question. Would that answer our question? How can I determine who is right? Is Grace right or is Jasmine right?
Jasmine.
How do you know? How do you know Jasmine's right? Or can you tell that Jasmine's right? What do you think? Ethan? Huh? Kevin, sorry. Ethan sat there last period. Okay. Okay. Well, yeah, I know that because I used that 24 to get the 2 12s. But does that answer the question of who's right, that 24 doesn't have books? Or is it Grace right that that's way too high, that 24 is too high?
24 is too high.
How do you know?
Because of our ratio constant, right?
So our ratio constant got us the 12, so we can see what Jasmine was saying. Critical piece of information you guys are missing. This is why we're doing these problems. You have to think about the whole problem. What don't we know? Bubbles? Okay, so let's do 7 times 12. 7 times 12 is 84, so is she right?
She's not right because
How do you know?
Grace argued that it was way too high.
Okay, so is Grace right? Is it way too high?
No.
Was 24 way too high?
No.
How do you know?
How do we know? Because 80.
What's missing, guys? There's a major piece missing here that we don't know, that we need to know in order to figure out who's right. What do you think? Technically, you can. You get a decimal, but you can divide 24 by 84. Bubbles? If I reduce, I'm just going to get 2 to 7. That's the rate that we started with. Okay, let me stop here for a second. Let's look at our tape diagram. What is our tape diagram comparing? What's the O represent? Okay, what's T represent? Okay?
How many people don't have
Big N?
48. 48 is 60. 60 is 72, 72, 84, 96, 96, 108, which is...
No. Overdue to total. This is the total students, guys.
It's up there.
This is the total students according to Jasmine. What don't we know? Bella? How many students are in the school, right? Do we know how many 6th graders there are?
No.
No. But we now have a number we could compare to see who's right, right? So, to answer our question, how can I determine who is right? No, by knowing how many students there are. So we need to know how many 6th graders. No, 6th grade, that's why I underlined it. 6th grade students. There are. Guys, do you understand that now? You see that that was our missing piece to understand who's right? If there are 84 total students, Jasmine was right. If there are less than 84 students, Grace is right. But we can't know who's right until we know how many actual students there are. Make sense? We can use the information they gave us and what Jasmine said to see what she thought the total number of students was, but we actually have nothing to show what Grace thought. We don't know how many students there actually are. Okay? But if there are 84 students, then Jasmine was right. Make sense?
Yes. Totally.
Okay. Let's go to exercise 1. Okay, again, please guys, get used to marking the text. Decide whether or not each of the following pairs of ratios is equivalent. So this is actually our direction. Decide whether or not they're equivalent. If the ratios are not equivalent, find a ratio that is equivalent to the first ratio. So we're given additional directions that they're not equivalent. If the ratios are equivalent, identify the non-zero number that could be used to multiply each number of the first ratio in order to get the numbers for the second ratio. Okay, so there's actually two steps to our process here. First, we need to determine equivalency. Second, we need to, if they're not equivalent, or if they are equivalent, figure out what the ratio constant was. If they are equivalent, are not equivalent, find one that is. Waffles?
We need to box it to find the ratio.
You could. The problem with boxing it is we're only going to do one of those two, so I didn't box it because it's really all based on this. So our first one, and I'll be honest with you guys, as soon as I start seeing equivalents, the first thing I'm going to do is make them fractions, because for me it's easier to really think about them. So if I'm looking at those as fractions, are they equivalent?
Yes.
Who said yes? Michael? Who said yes? Does everybody agree with Michael? Why are you shaking your head no? You don't think those are equivalent? See what? Guys, please, let me... Why are you saying they're not equivalent? Why are you doing 6 times 8? Isn't it 6 times 7 is 42?
Yeah, no. That's why they're not equivalent.
Why?
Because bottom one's 11 times 8.
Oh! And the top one is? Oh, so those aren't equivalent? That's not the same number?
No.
Guys, remember, I told you, I'm going to question you whether you're right or you're wrong. You did a very good job of defending your answer. Just because I question if you say the right answer, don't think you're wrong. Defend it. You defended it very well. That's exactly what I want you to do. Well done. No, those are not equivalent. I did not use the same ratio constant to get my second fraction. That is one of your options. Remember, when you go, if you guys look back at your notes, we kind of gave you 3 options to look at, right? First is, and it's in the definition of equivalent ratios, they simplify to the same form, right? So let's do that version. Okay, 6 and 11, I can't divide those by 2, 3, 5, or 7, so that's simplest form. 42, 88, what can I divide those by? 2. So I'm going to divide those by 2. That gives me 21 and 44. Can I divide those by 2?
Yes. No.
By 3?
Yes. Wait.
No.
By 5?
No.
By 7?
Yes.
No.
Wait. No.
If I say no 4 times, guys, I'm in simplest form.
Yes.
With the possible exception of a second hidden factor, which we had because there's a 2, I can divide that by 2 and that by 3. So you may want to check that just to be safe, but it isn't. So that is simplest form. Is that the same fraction in simplest form?
No.
No. That means they are not equivalent. Okay? Your third check that I gave, well, so the first check was ratio constant. Second check was, do they simplify to the same form? Third check was, anybody remember? No, that's the simplifying. You remember the third way? Cross multiplying.
Oh, yeah.
Remember that?
Yeah.
So that's our third check, and you can do any of the 3. Any of these will get you the correct answer. So if I cross multiply, these numbers aren't that bad. 88 times 6, 48, 528. Remember to write it on the side that you did it towards. And then 42 times 11 gives me 42, 42, 462. Are those the same numbers?
No.
528, 462?
No.
No. So they're not equivalent. I didn't get the same result when I cross multiplied. Now, again, the reason I like cross multiplying, which fraction is bigger, 6/11 or 42/88?
42 and 88.
Nope, 6/11. Because 528 is bigger than 462. So when I cross multiplied towards the top, this number is bigger than that one. So that means that our first fraction is bigger. Okay? So, were they equivalent?
No.
No. So we're going with the second one. We'll check that box. So what would be an equivalent ratio? What ratio could I get that would be equivalent to the first ratio, 6/11? No? 4277. So she said, okay, I did the top times 7. If I do the bottom times 7, I would get 4277. Make sense?
Yes, sir.
Everybody good so far?
Yeah.
Okay. Does that make more sense checking the equivalents now?
Yeah.
Again, I showed you 3 ways. I don't care which way you use. Pick the one you like. That's what we're using this V, and I will always try to show you multiple ways. There's a lot of different ways to do math. Pick what you're comfortable with. Okay, let's look at our second one. 0.5 and 0.20. Are those equivalent?
Yes.
You said yes. Do you think those are equivalent?
Yes, they are. Yes, they are. Yes, they are.
You guys will get to know and love me. It may take some of you a little longer than others. Why did you change your mind? Why are they equivalent? Yeah, you got to be thinking in math. Why? Why do you say they are?
Because if you do 5 times 4, well, if you do 0 times 4, it's going to get 0, because anything times 0 equals 0. And if you do 5 times 4, you get 20.
Awesome! I love your thinking. 5 times 4 is 20. 0 times 4 is 20. I have the same ratio constant.
0 times 4 is not 20.
Or 0 times 4 is 0. Thank you. That was an actual mistake. I didn't try to set you up on that one. So yes, 5 times 4 is 20. 0 times 4 is 20. But here's the problem. What if I did 0 times 8? Is 0 times 8 0? So did I always use? Do I know I use the same ratio constant?
Yes. No, you won't.
So let's do a second check. Let's check it a second way to see if we can still determine if they're equivalent. What would be another way to determine if they're equivalent? Cross multiply? Okay, so if I cross multiply, what's 20 times 0? What's 5 times 0? Did I get the same result?
Yes.
Okay, what's our third way? Simplify, right? Can I simplify 0 over 5?
No.
Really? Can I divide them both by 2?
No.
By 3?
No.
By 5?
Yes.
What can't I divide by 5?
Zero.
So I can't divide 0 by 5?
No, you can.
5 times 1 is 0.
Zero.
So can I divide 0 by 5?
No. Yes,
Yes, I can. I can divide 0 5 ways, it's still 0. I can divide 0 80 billion ways, it's still 0.
Yes.
Never gonna change.
I can divide 0 by anything I want to. It doesn't change. It's still going to be 0. So yes, I can divide it by 5. So if I divide them both by 5, I get 0 over 1. What about 0 over 20? Can I simplify that?
Yes.
What can I divide by?
5.
5, okay. Divided by 5 gives me 0 over 4. Can I divide that? Simplify it further?
Yes.
What can I divide it by?
2.
2? Gives me 0 over 2. Can I simplify that?
Yes.
5 gives me?
1.5.
Do I have the same fraction in simple form?
Yes.
Are they equivalent?
Yes.
Everybody seeing it?
Yes.
Good. Okay. So, yes, they are. What was my ratio constant? What did I do in the initial one to get to the same number?
You multiply by 4.
By 4. So my value of C is 4. Everybody good?
Yeah.
How you feeling on this? Thumb meter? Thumb meter, guys. It does that. Okay, so we got a few in the middle still. Let's do another problem to try to help see if we can do this a little more clearly. Go ahead, Kate.
Okay, let's look at the next one. Who wants to read it?
I don't know.
That's not your hand. No. Hold on, sweetheart. Hold on. And she has a soft voice. Okay, go. Okay, I can't hear. Okay, all right. Let's look at what we need to. Good job, Winter. She's underlining, circling, boxing. Okay. What do I need? Let's start with circling. What do I need to circle? 5 to 6. Or 5 to 6. What else? 5 to 6. Another one. Okay.
54.
54. Good. And can I go ahead and circle cashews?
Yes.
Why? It's a unit. Good. So I might want to go up here and circle walnuts and cashews. Those are my units. Very good. What do I need to underline? We're going to underline our math words. Number, ratio, mix. Okay. I don't know about mix, but I'll go with number and equivalent. Where's our unit? Unit. What about boxing? What do I need to box? Okay, justify your answer. Good. That's an instruction. Justify your answer. What else? Use a tape diagram. There's an instruction as well. This is something we need to do. Another one. I'm going to wait till over here we're ready. There's a lot going on here. And right here. Okay, talk to me, yes.
Justify your answer by showing the new ratio you created of the number of walnuts to the number of cashews equals 5 cents.
Very good. Okay, so I didn't box that whole thing, but I did box justify your answer. Is there something else we're supposed to do? Yes, Winter.
Determine the number of walnuts that are in the bag.
Very good. Here it is. Determine the number of walnuts that are in the bag if there are 54 cashews. Okay? It tells you what you need to find, how you should find it. What are we going to use? Tape diagram. I heard it. Thank you. All right, and then we're going to justify. Basically, you're going to check your work. Show me why that is correct. Okay, let's start with a tape diagram. What am I going to draw? What's my initial ratio? 5 to 6. I heard it. Good. Okay, what label is on top? 5. What label though? My unit, I should say. Yes, talk to me too. Why? Okay, and why is it on the top, label on the top? It's the what? Yes.
Because it's saying use in a bag mix walnuts and cashews.
Okay, and what do you see first?
Walnuts.
Yes, correct. So both of you were correct. Good. Walnuts and then cashews right here. Okay, now, what are we trying to find? Or I should say, what do we already know? What do we already know? Yes, to know. It's 54. So if I know that the number of cashews is 54, what am I going to do from here? What do I need to find? Talk to me, Megan. Okay, where did you get 6 from? Right, in the ratio, right here. Guys, 1, 2, 3, 4, 5, 6. So she's going to divide it by 6. What is 54 divided by 6? I heard it. What is it? 9. So that's my ratio constant.
Wait, well, why again would you just divide it by the...
Okay, so how many walnuts are there? Yes, sir. 45. 45. Okay. So, our answer is there are 45 what? Yep. Okay, that's our unit. Okay. Any questions so far? Is everybody clear? Is that you? You are doing awesome, all of you. Okay. Now, how are we going to justify this? How are we going to justify this? What can we do to check it? What can we do to check it? I've got my original ratio, and then I've got 45 to 54. It says justify your answer by showing that the new ratio, right here, new ratio is equivalent to 5, 6, yes. Cross multiply. And like I told the last group, I'm not going to do the word 40. So what is 54 times 5? 54 times 5 is what? What? I'm going to let you check that. What is it? Talk to me, Zachary. What? What is it? You want to find a friend, Zachary? Okay. Oh, what? He said yeah? Okay. 270. Kyrie said, Kyrie, right? Kyrie said 270 right here. What about 6 times 45? 270, go figure. Are they equivalent?
Yes.
Yes. Yes, they are equal. Okay. Any questions? Okay. Okay, the next thing we're going to do, I'm pretty sure. Guys, this is your homework. This is your homework sheet right here. Okay? No. Go ahead and tear this out. All right? I'm going to wait till you tear it out, and then I need you to listen. Tear it out, close your module. I'm going to look for those that are ready. Right here, ready? Tear it out. Tape. I have not given any more instructions except for tear it out and then close your module. 2 things. Tear out your homework, page 15, close your module. 2 things. I'm looking for those that are ready. 1, 2 things. That's it. And when you're quiet, I'll know you're ready. Still talking. Any questions over here? Okay. 1 page. Page 15. Okay. We're ready right here. Over here. Awesome. Awesome. Guys, these are some rock stars over here, right here, here.
Even just rocks.
I don't know what's going on back there, but I know that we're ready here, here, and here. Okay, now listen. Still talking in the back. You need to keep your homework out. You need to keep your homework out so that Mr. Moore and I can come by and check it. Make sure your name is on it. You also need to get out a sheet of lined paper, blank paper. Okay? After you do those two things, get your homework out, blank paper, go put your modules away, and then Mr. Moore's going to give you some instructions. I think I do it. Alright?
Okay, so this was classwork. This goes in as a classwork grade, which is one of the things that you'll see in grade 3 when you guys start looking at your grades. I personally haven't put any in yet. I don't think Miss B
I
has.
don't have that.
Okay. So once Miss B gets access to start things in grades for her. But basically, it really doesn't matter if it's classwork or homework or where we do it. Every point you get is worth the same amount. So it's really important that you stay up on these things. Remember, we grade on completion, not accuracy on this type of thing. So those of you who decided to sit and make that a social hour instead of actually doing your work are not going to get full grades on that. That's also why you have pens out right now instead of pencils. So let's go and go through this. The ratio of red roses to yellow and pink. So that's where our initial notes said be careful of words like and or or, that's how you put things together, right? So if I look, but on this side of the two I've got red. How many red roses are there? 3. How many yellow and pink? 6. So what can I simplify that by?
1 to 2.
3. Make it 1 to 2. That should be your final answer. So if you add 3 to 6, that's half credit. So minus 1/2. 1 to 2 is full credit. What's the ratio of yellow and orange to all roses? So yellow and orange, I count that up. I see 6 of them. All oranges, there's 12 total in the bouquet. I can divide both those by 6, and I get 1 to 2. Okay? For our Candy Crush, ratio of green to purple. Green, I count, I've got 5. Purple, I count, and I see 4. Can I simplify that? Nope, so that's final answer. What's the ratio of all the candies to the chocolate candies? So if I count, that's 5 by 5 gives me 25. Count the chocolate ones, I see 5. Divide both those by 5 gives me 5 to 1. Okay? Poly paint. Ratio of purple to all the paint on the first row. So purple in the first row, I see 1. All of them, I see 1, 2, 3, 4, 5, 6. Can I simplify?
No.
Nope, that's my answer. Ratio of purple, yellow, and blue to gray. So when I count them, purple, yellow, blue, I see purple, yellow, blue. I have 3 of them. Gray, I only see 1. Can I simplify that one? That was it. So those should have been your 6 answers, yes.
So 1 to 6, I didn't see all the rest of the first row. I don't think it was 7 before.
That's okay. Again, guys, so great example here. He only saw 4. So instead of, here it is, 1 to 6, he had 1 to 4. He gets that wrong. What's his grade if he did all 6 of the problems? 5. Because he did them all. Now, if he, like I saw a couple of you, didn't get to 2 of the problems, so he did 4 out of the 6, what's your grade? 2.5. Turn them into the basket. Make sure their name is on it. My guys on this side, the C's on that side.